Hey, everybody, this is Larry. This is day 10 of the June Legal Day Challenge. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about today's problem. So hopefully, you enjoyed the intro. Yeah, I don't know. Earlier today, I had a power outage. Apparently, it happens like once or twice a year in Aruba. So was planning to do some coding and stuff like this, but no power, no coding. So, but now I do have power, and hopefully, this is not what. That's not what I do. All right, that's good enough. Hopefully, knock on wood, we'll have good power and internet for this problem. Today's problem is longest substring without repeating characters. Okay, this is a very early problem. It seems like because it's literally number three. Yeah, and I feel like was that yesterday's problem that we just did? That was two pointers. Yeah. So basically, this is an idea, another idea of greedy slash two fingers. But this one is a little bit of a variation in that it is sliding window. So sliding window is greedy in that the solution is one of the different ways that you can do as long as you hold an invariant. It's not always easy to prove, but this one you can kind of think about it as like I don't know, you get a state that is true and then you wiggle it a little bit and then see how long you can extend it and it's still true. If it's no longer true, then that means that there's one of two things, right? That means that let's say let's say you have here, you have ABC and then now you see an A. Well, obviously this cannot be, there is a repeating character there, so it cannot be the longest substring, right? Well, there are only two ways to do it. One is removing this A, which we already checked. That's the idea. And then the other is removing this A. And then this can be a possible longest substring. Of course, you can keep on extending it. In this case, not actually, but that A is now part of the longest substring and see how long that can go. So in that way, it is sliding window, it is greedy, and it is two fingers, two pointers, whatever you would like to call it. Yeah. Yeah, let's go. I don't really have anything else to say, so yeah, n is equal, let's just implement. So then I have the left pointer is equal to 0. Yeah, I mean, I think so. One key thing with programming in general, but especially with these two pointer things, is trying to think about whether you want things inclusive or exclusive. Because basically, the way that I think about it is that I have two variables, right, or two pointers, like I said, and now I have to think about whether they're inclusive or exclusive. So I was going to write something like this, but the way that I'm actually going to write it is for right is in range of n, and then s of we do something with s of right. So that means that right will be inclusive by the time that we get incrementers, right? And then left will also s of left will also be inclusive. Oh no. S of left will be exclusive inside the set, right? And okay, I think that's good. Basically, now we have a set of characters. Let's just say we call it scene, and then just the longest for 0, something like that. Maybe even default to 1, but maybe 0 is an input. Yep, 0 is an input, so you can do that. But yeah, and then the idea here is that right is inclusive, left is exclusive inside the range. And it's just about letting us write these things a little bit easier. So sometimes you want to think about whichever one is easier to code, which one is easier to explain, and all these things, right? And here, yeah, so now we process this so that at the end of this, I guess technically right is not inclusive, but by the time you there's no operation between right and you execute it. So then now basically if s of right is in scene, well, or while this is in scene, I guess technically, yeah, right, s left or scene that remove, is it remove? You can also, yeah, and then, and here we know that this is exclusive, or we say that this is exclusive because s sub left is inside the range, right? That means that the left variable is not inclusive. So yeah, and then left re-increment. And that's pretty much it, I think. What's it called? S scene.s of right, longest equals max of longest and size of the scene. You can also keep in a variable, but it's fine, I think. And then I think that should be good. Unless I did something stupid, which happens a lot actually lately. Okay, looks okay. I think the only tricky case is empty, but I think that's okay too, unless I have some like out of bounds type thing, which I don't think I do. Could be wrong though. Of course, that's why we test, because we don't know. Give it submit. Cool. First try. 801 day streak. Cool. What is the complexity here, right? Well, the complexity here is going to be O of 1 because each character will be at most added to scene once and removed from it once. So in total, even though there's a while loop here, so sometimes a little bit confusing, in total, like I said, all the numbers will be scene used, added and removed from scene 1, so that should be good for linear time. In terms of space, well, what is the space, right? Would you say there's a linear space? Trick question. The answer is no. No, right? Because technically, scene is not O of n. Scene is actually O of a, where a is the size of the alphabet. And in this case, the alphabet is, actually, I was wrong. So I was going to say 26, but as you can see here, it has digits, symbols, and space. So it's even like O of, I don't know, 40 or something like that, depending on how many symbols there are. So yeah, so this is actually O of alpha, so you can kind of adapt it to the number of characters. And yeah, that's the space. So let me write it again. So O of n time, O of alpha space, or technically O of a plus n. Or that's notation for it, though technically you really want, I think some people would get nuts about this, something like that, right? Is that even true? Yeah. Space. So that's pretty much it. That's all I have for this one. Let me know what you think. Let me know what you think about the intro. Stay good, stay healthy, to good mental health. I'll see you later and take care. Bye bye. Oh wow, 10 million submits. Anyway, see you later.